Hi everybody, look, I've had this question a couple of times and I found it a little bit difficult to explain via email and text. Not that I'm texting anyone, text on email. So it's transformation. We've got matrix 1, 0, 0, minus 1, so it's some sort of reflection, I think, in the x-axis, times our original point, our original coordinates, plus a translation of 5 degrees in the positive direction of the x-axis. It doesn't really matter what those transformations are because we're just going to multiply out the matrices and work it out. But I think the difficulty of this question is that it's transforming a function which we don't know, function f, to the graph of y equals x squared. So y equals x squared is actually a transformed function. And we've got to work out what the original function was that goes through this transformation and then provides y equals x squared. So I'm going to start off by doing that matrix equation and expanding that. I guess I probably need to have a pen, don't I? This is all very new to me. Okay. So we've got 1, 0, 0, minus 1 by xy. I'm going to write over that yellow bit, plus 5, 0. Okay, we multiply that out, we take that first row, multiply it by our only column, so that gives us x. Now I'm taking a couple of steps at once here. Once we've done this, we're going to add this second column matrix, and so instead of just x, it's going to be x plus 5. And bottom row, we multiply by this column, we get minus y, and we can see that's plus 0, so I'll just write minus y there. Now that's equivalent to x dashed y dashed. Okay. Alright, so this question is saying that our transformed function is y equals x squared. Actually, before I say that, we should just write these out as equations. X dashed equals x plus 5, y dashed equals minus y. Okay. Now, because our transformed equation is y equals x squared, this is where we have x dashed and y dashed. So we can say y dashed equals x dash squared. Okay, then we can say, okay, but we can just substitute what we've got there. So we can say, if we're trying to work out our original equation, we say minus y equals x plus 5 squared. So y equals minus x plus 5 squared. And y is just the same as f of x. So the answer is A. Okay. Now, if the question, so that's the question. I'm going to change colours just to show that I'm changing tack here. If we instead think, if the question had said this transformation transforms y equals x squared into something else, then we still would have had the same matrix equation and still would have come out with the same result. X dashed equals x plus 5, y dashed equals minus y. Okay, that's dashed. But because we want to find out the transformed equation, and we have y equals x squared, we want to solve for y and x. So x x equals x dash plus 5 and y equals minus y dashed. So we then substitute in our function y equals x squared. We get minus y dashed equals x dash plus 5 all squared. Okay, and that would be, we can just drop the dashes at that stage and say, okay, so our transformed equation will be y equals minus x plus 5 squared. It's the same, isn't it? Oh, playing with that mouse. Put it away and then do it. Okay, look, hopefully you all spotted my mistake there and you're all screaming out, hey, that's wrong. Here I wrote, trying to solve this very simple bit of algebra. I got it wrong. X would in fact be x dashed minus 5. So let me just get the eraser out. That can work, did it? X dash minus 5. Now put that away. Come back to my pen. Of course, I should have rubbed it all out. So y dashed equals, I'll just cross it out and put minus 5, x dash minus 5, minus y equals x dash minus 5 squared. And of course, y equals minus x minus 5 squared. And of course, we can just think of that as f of x equals minus x minus 5 squared. And that would, if that had been the equation, that would have corresponded to C. In fact, it also would have corresponded to B. These are in fact the same answer, because when you square 5 minus x or x minus 5, you get the same answer. So we can write this. I can never find where this is. Answer B or C. Okay. So you see the answer is different depending on whether y equals x squared is the original function you put through the transformation, which I've done in blue over here, or if it's the result of the transformation, which I've done in red. And if it's the result of the transformation, we need to solve for x dashed, y dashed. If it's the original function, we need to solve for x and y. And that's why we get those different answers. Hopefully that helps for those people who are asking that question. Thanks very much, and I hope you spotted my mistake.